Good afternoon, everyone. Um, I want to touch upon where Partho left. He covered a lot of ground from the spatial uh, context from the space. I wanted to also touch upon some of the technologies that Maxar is indulged and invested into in terms of scaling up for a number of applications that we are talking about today. First of all, congratulations to everybody for the release of new geospatial policy. As I see, the policy envisages bringing about scale, speed, and accuracy by using all the modern technologies that are available to advance the development agenda of the nation towards a $5 trillion economy in next few years, hopefully. So with that context, bringing the scale, speed, and accuracy, we are today spoiled with a number of choices that we have. So it all depends on a number of factors before you select the right technology to be used in that particular context, depending upon three main considerations: the scale, which is the extent of the geography under consideration, the frequency at which you would need the data, and of course the details in terms of accuracies and precision. So we are today spoiled with choices depending upon, as I said, the application under consideration, from a resolution of 1 kilometer going down to 30 meter to 30 centimeter, where Maxar satellites capture the images from space. And we are introducing a middle layer of 15 centimeter using our proprietary high definition technology to even make the 30 centimeter images more clearer for advanced machine learning and AI applications. Of course, drones and aerial platforms have been used in the recent times, and with opening up of the geospatial domain in India, there's a number of possibilities that we can think of. So if we were to plot these factors into three dimensions, looking at what details are needed, to what geographical extent is under consideration, and of course the frequency desired, you have a number of tools and technologies to choose from. And if you were to plot a few other factors, the cost and time invested in bringing about the application, you would have a certain graph that you see on the screen that would guide your decision for the choice of right technology. So from a Maxar standpoint, Maxar has been in the space industry for last 60 odd years. It has two distinct business interests. One is in the space infrastructure, which includes designing and manufacturing a number of different kinds of satellites, from communication satellites to weather satellites to, of course, Earth observation satellites. In the space infrastructure, it also deals with the outer space missions to Moon, Mars, International Space Stations, and so on, by providing a number of robotic technologies to advance those missions. The other part of Maxar is invested into Earth intelligence, and by virtue of owning and operating their own very high resolution satellites for the last 20 odd years, um, it's been delivering the Earth intelligence products and services to the market. So what you see on the screen is a range of satellites, starting from the earliest satellite in 1999, which was Iconos, the first sub-meter satellite commercially available to the world, to the most advanced satellite, which is WorldView 3, which captures images at 30 centimeter resolution with the precision of 5 meter CE90 accuracy, which is equivalent to 2.5 meter RMSE. The satellite is a little unique in its design because it carries two spectral cameras. One camera captures multispectral data in visible and near infrared in 8 distinct multispectral bands, as the second camera, which is designed for capturing the shortwave infrared information in 8 distinct spectral bands. So it brings about both the scale, the multispectral capabilities, and this constellation of 4 operating satellites as of today captures images twice every day in any part of the world. But what is happening in the year 2021, in the later part of 2021, is the launch of new constellation, which is called as Worldview Legion. This is a set of 6 30 centimeter class satellites launched in a configuration that allows us to capture imagery at least 15 times in a day. So Partho alluded to the ability to capture intraday. This will add our ability to capture a number of images over an extended period of time in a given single day. Now, this provides a very robust toolbox at our disposal that captures the application considering those 3 parameters of detail, the scale, and the frequency. So this chart shows the number of revisits depending upon the geography under consideration, from 7 times in a day to 15 times in a day. This also opens up an opportunity for us to capture data even at night. And this is an example. This image was captured at night on the day of the new US administration inauguration of new president in the United States. This is a picture of Washington, DC, captured at night. So the point being, this opens up the whole horizon to capture data in an extended window, faster, better. The other point, with all these advancements in the constellation of these satellites, is how do we bring down the latency from tasking to the end user's application. So today, considering all that we have in place, it takes about 24 hours to get the data from the satellite on the ground and in the hands of the user. But in many time-sensitive applications, 24 hours may not be good enough. So our intention in the future investments on the technologies is to bring down this latency to 60 minutes from the time of the capture. And this involves a number of technologies that are in consideration today. So I wanted to show you this whole notion of scale, where we are dealing with issues, challenges that are at national scale. India being 3 million square kilometer in its landmass, if we do not include the maritime zones, that itself is a huge amount of area to be processed. But at the same time, we are also looking for the details and precision, which can give us sufficient insights to deal with the many challenges that are spoken on this forum. As I said, we are also introducing new technologies to make the imagery even more clearer and crisper. And these are some of the examples of the high definition class images at 15 centimeter resolution captured by these satellites. Now, Maxar has been operating these satellites for the last 20 years and all those data that has been captured a number of times around the world is available for access through this online cloud platform called as Secure Watch. It gives us an opportunity to look at in retrospect, and I want you to look at this screen just for a minute. This is a minute time lapse over an area near Mumbai, and you will see how the landscape has changed from a lush green mangrove population to be completely denuded of the vegetation. This is one of the concerns in the context of managing water related issues in India, is the understanding of what is making the largest impact on the water resources. Obviously, the development agenda is in place, but that development agenda cannot replace the environmental concerns that we have that eventually bring us down to the water scarcity, the droughts, and other aspects of water related issues that we are talking about. Now, when the images are captured, as I mentioned, India is nearly 3 million square kilometer in landmass. When these images are captured, these are captured from different sensors, different times of the day, or different times of the month, by different sensors, and they don't look alike. And so there's a huge amount of heavy lifting that needs to be done. As such, these images are quite heavy in size. To be able to handle these images, to bring it to a mosaic, a color balanced mosaic stage in itself is a huge task. So by using all the machine learning and AI techniques, the whole of India at 30 centimeter is available. So you have the scale here. And when you zoom in, you also have the details to map all your surface water resources, the other related infrastructure for water resource management. Now, when it comes to supply and demand under the Jal Shakti mission, where every household in India needs to have the water supply, a demand analysis needs to be done. And I'm not sure if India has sufficient maps or maps in sufficient details to undertake that analysis. So here is an example of how the high resolution imagery, together with the technologies in AI and machine learning, could help speed up the process of feature extraction, be it water features, or be it transport features, or be it just the households and building extraction. My last point here is this is all good in 2 dimension, very precise, but if the same thing can be done in 3 dimension, it would be even better. So Maxar acquired a new technology late last year called as Vricon, which brings a unique patented method of using multiple satellite images collected over a period of time. These are, of course, overlapping images. So shifting from traditional stereo pair photogrammetry to multi-view photogrammetry and creating the world in 3 dimension. So our intention is to create the whole world in 3 dimension at 50 centimeter resolution to start with. And these elevation models are accurate up to 3 meter in absolute spherical error, which is a better representation than just the LE90 for vertical accuracy and C90 for horizontal accuracy. Now, the unique part of this technology is that it does not use any ground control point, which of course, if you are dealing with a scale like 3 million square kilometer just for India, or globe, which is 150 million square kilometer, it is nearly impossible to use ground control points in such process. So here, this technology uses the archive imagery, uses no ground control points, uses artificial intelligence and machine learning to create elevation models at scale, and we have intention to create 50 million square kilometer by the end of this year. Now, this is not a simple, just the terrain model, the usual terrain model that we are used to. These are very high fidelity, high precision, highly detailed terrain models. So here is a representation of a surface model. But when you take the high resolution satellite data and drape it over it, and this is not just simple draping over the terrain model, this is actually a true three-dimensional representation, which is essentially called as a digital twin. So we create a digital twin of the Earth, which becomes the foundation for us to extract all features of interest, including the buildings, trees, the other features of interest as well, in a GIS-ready format. And of course, as a byproduct, we also have a true orthorectified imagery created of the process. Now, I want to leave you, in the end of my presentation, leave you with this video, which kind of captures the whole process of how these images are captured in space and how the technology from Vricon uses the multiple images collected over a period of time to turn them into three-dimensional representation of the Earth. Now, the throughput of this technology is quite high. We can do 1 million square kilometer of production of this kind of three-dimensional data in a month. So we are talking about nearly 3 months to produce whole of India in 3 dimension with the precision that I mentioned, 1 meter in relative and 3 meter in spherical error, which is unparalleled if you consider all your trade-offs of cost, time, and the details that you require. So it's a unique combination of the technology in space, the technologies on ground, that's gonna bring the speed at scale and accuracy with the speed that we desire today to address all the challenges that we are talking about today. So with this, let me end my presentation.